Alright, so let's continue from where we stopped. Now, start at prime number. What is prime number? Prime number are numbers that can only divide themselves and one and itself. Okay, it can only be divided by itself alone and one as well. So that means this kind of number they don't have any other factor. The only factor they have is themselves and one. So example of prime number is 2, 5, 7, 11, 18, 17. You know these numbers they have one thing in common. There's only one that can divide them that will not remain or by themselves. 11 divided by 11 is 1. 1 divided by 11 is 11. So there's no other number again. So the only factors is just 1 and itself. That's all. Now, I have prime factorization. Prime factors. Prime factors means that numbers that are prime number and alone. For example, like the example I did the other time. Okay, prime factors of 12 is 2, 3, 2, 2, 3. 3 is about 2 and 3 now. For 14, 2 and 7. You can see these are prime numbers. The factors are prime numbers alone. So you can't see any number among these that is not a prime number. Now let me show you an example of what I did, how to get a prime number. Now let's say this is 30. The question is to look for the prime number or prime factors of 30. 2 divided by this 15, 3 divided by this 5, divided by this 5. Now the prime factor for this will now be 2, 3, 5. And okay, 1 is not a prime number. No, I think I didn't mention that. 1 is not a prime number. So the first thing, so 1 is never a prime number. It isn't. Okay. Prime numbers start from 2, 2, 3, 4, 2, 3, 5. Because a lot of people make that mistake. Prime number does not start with 1. So now, so if you're supposed to look for the prime number now, it will be 2, 3, 5. 15 cannot be prime number because apart from 15 and 1, other values can divide this. 32 is the same thing. So, okay, let's just do it this way. Let's just write out all the factors. So this is like a universal set. If you understand set, this is where all the factors is. These are all the factors of 30, right? So the prime factor from this will now be 2, 3, 5. 6 cannot be a prime number or factor. 10 cannot be, 15 cannot be, 30 cannot be. So just 2, 3, 5. Same thing to 75. These are all the factors. If you divide to get all the factors, they now pick out number that can divide itself by 1. That's 1 is not a prime number, so 3, 5, just 3 and 5. You understand? So these are the things you need to consider. Let's use 2 for example. It's 2, 2, 3, right? So 2, 2, and 3. Those are the prime factors. Here, so I think I'm done with that. Okay, so the other composite numbers, those are the numbers that are not prime numbers, are not prime factors. Those are the other numbers that one can divide, they can divide, and they have more than one number that can divide them. And their division is not set to 4 and 1 alone. The number and 1 alone, the other number, for example, 4 now, 2 can divide it, 4 can divide it, 1 can divide it. The same goes to 6. 3 can divide it, 6 can divide 1. So those are the things. If you have another number that 1 can divide, itself can divide, and another number can divide. So that is composite. Composite means mixture of something. Now, fraction. This is a format of fraction. The numerator, denominator, a over b, as rightly ascribed here. So, for example, minus 7 over 5 is a fraction, right? Minus 7 is the numerator, 5 is the denominator. So, if Now, I don't want to mix things up. I don't want to go to unnecessary details. I don't want to go straight to the point. These are fractions, it's things talk about rational addition, stuff like that. What they are trying to talk about is that minus 7 over 5. If you multiply the numerator and denominator by the same value, it's equal to give you back this value. That's what they did. They multiplied the numerator by 4. They had minus 28, divided by 5 times 4, that's 20 again. So if you divide through, you're still going to get minus 7 over 5. So it's the same value. And here again, they can, instead of saying minus 7 over 5, this is the same as 7 over minus 5. So as long as carrying negative value. Now, let me quickly talk about the most important thing. Yeah, these are if you want to talk about division of fraction. This is division, so you should not understand this. I should not be telling you this. If this sign here, okay, let's talk about the multiplication first. No, sorry, addition. Addition of fraction. Minus 8 over 11 plus 5 over 11, right? We look for the LCM. Like the UC teachers. LCM. So LCM here will be 11. Write 11 below. Now, 11 divided by 11, that's 1. 1 times the numerator, that will be minus 8 plus this 11 divided by the other 11, that's 1 also. 1 times the numerator, which is 5 plus 5. To do that, you have minus 3 over 11 plus minus 3, minus 3 over 11. So that's the addition. Then we go for the subtraction. So you just have to work it out. These are things you know. I won't go deep into it. Now, for balancing sake, let's say the negative sign is here. The same thing. You look for the common 3 and 5, right? Look for the lowest common LCM. Do the LCM, you're going to have your LCM to be 15. And you do the same, but I don't like working out. It slows me down. So why don't you just multiply all through each side by the product of these two? 3 times 5, which is 15. 15 times 1 over 3 plus 15 times minus 2 over 5. So 3 divided by this, that will be 5. 5 divided by 15, that will be 3. So when you do it that way, I'm going to solve to get this answer on 1 over 15. However, if you want to do the process the other way I explained, you look for the denominator to be 15. 3 divided by 5, 15, that's 5. 5 times 1, which is the numerator, that's 5 plus here 3 divided by 15, which is 5, which is 3. 3 times minus 2, that will be minus 6. That will be having. So when you do the calculation, you get the answer. But I prefer to multiply through. For example, since this is 3 and 5, these are the denominator. The product multiplied by each fractions. 15 times 1 over 3 plus 15 times minus 2 over 5. So you do that, you get your answer fast. Now, multiplication of fractions. You multiply, that's easy. Then that's minus 10. 7 times 3, that's 21. So minus 10 over 21. Now, division. That will be 17 over 8. Division of fraction divided by 3 over 4. Now, this sign has to change. When this sign changes, for you to solve this sign has to change. And when this changes, the denominator will go up and it will exchange. So, for example, when you change this to a multiplication sign, it means 4 will be up, 3 will be down. So that's just the explanation. So when you do that, that's what they did here. 17 over 8 times 4 over 3 over 3, which is because the sign, the reason why there was an inversion because of the multiplication sign. And when you multiply it, you get your answer. Now, mixed number, mixed fraction. Mixed fraction is when you have, for example, now I'm talking about remainder the other time. This one would be like 4 point something or 4 whole number 3 over 8, right? Now you can convert it to fraction. How do you do that? When you do like this, okay, let me take my time. I said these are different numbers. 4 plus 3 over 8. Alright, so this 4 can also be 4 over 1, and you solve it, but or you can solve it on your normal fraction. 4 over 1, the denominator will be 8, right? You write your 8, then you do it as I've been explaining, you get your answer. You get it? So if you want to convert, the best way to convert, and this process is just too long for me. If I'm the one I want to do it, I'll just keep through all this and get the right answer. What do I mean? If you want to convert it to fraction, this is the best way to do it and fastest way. Multiply the denominator, which is 8, times 4 is the whole number, plus the numerator, which is 3. That will give you 35 over the numerator, which is 8. That's the trick. So 8 times 4 plus 3 give you 35 over 8. Then we go for all of this. Same trick. Stop. These are things that you know, so I should not be going deep into it. You understand? Deep into it. All these one are just sign. So you can do this one is like 1 over root 2 divided by 3 over 5. And remember what I told you about division? You can just like the other one I show you, like this. This sign is already there, so we just flip this one. So by the time you say 1 over root 2 times root 5 over 3, you solve your answer. These are not what you have here, see. So the next video I'm talking about exponential and roots. I'll give you this material to read. Really, you should read it yourself because you get the best out of it yourself. That's what I will do for you. So far I've been able to do some stuff, and we'll continue. But for now, we still have a long journey to go with this mathematics. Let's talk about exponential, talk about decimal, real numbers, ratio, percentage, stuff like that. So thank you very much for your time. I really appreciate you. Let me just use the remaining time to talk about the GRE and how to pass well. The secret of GRE really is practicing. The question is not going to be difficult, but it's going to be very, very tricky. And not going to be a question that is too difficult, although the English might look somehow difficult. That's the difficult part, but the maths is things you know. So you just need to be smart. Practice so that you get used to the way they set question. You have your own way of answering question, and this will really help you, and it will even give you confidence when you are solving. I really hope so just practice more. In fact, don't even limit yourself to whatever I teach you. Go on the internet, read about topics that you don't understand, solve question, read a lot of book, stuff like that, and get yourself ready for this exam. You understand? And any comment, anything you don't understand about my teaching, please let me know so that I can do a video to rectify that, or to that effect. Thank you. Now, I made a mistake when I was talking about prime factor, using this as an example. Prime factor, I'm repeating. Now, prime factor, since all these numbers are used and they were able to divide the number here, so everything here is a prime factor. 235, no, I already told you the characteristics of a prime factor. Now, the same thing goes for you. So the prime factor for this one is 235. Although that is correct based on what I said the other time, but for this second one, here's why I made a mistake. Since we used 355, so I'm going to concentrate on this. So that will be 355. So 355 is the prime factor. And so that's all. That's why the last place when you use 12 for prime factor here. So 2 2 3, right? So we use 2 2 3. So that's the answer. Thank you very much, and have a nice day. And see, it's the same thing that they use here. Prime factor numbers that can divide themselves and 1. Just pick it out.